Have you ever wondered how to find the dimensions of a box? Well, if you have, that's strange, but you've come to the right place. So let's start on this problem. It tells us that the length is going to be 1 inch more than the width, which is then 1 inch more than the height. And it also tells us the total volume of the box is going to be 86.625 cubic inches. So on a problem like this, remember the goal is to determine what is the length, what is the width, and what is the height. It's saying that the length is 1 inch more than the width, and the width is going to be 1 inch more than the height. So what we could do is, it sounds to me like the height is the smallest value, right? So let's make that our variable. You can call that x or just leave it as h. Just leave it as h, that's fine. And then it told us that the width here is going to be 1 inch more, or 1 plus the height value, right? So if the height is 10, this is going to be 11. And then it also said that the length is going to be 1 inch more than the width. So you can say, well, that'll be 1 inch plus the width, right? Which is 1 plus h. So right, this is just a complicated way of just saying 2 plus h. Okay? So those are the dimensions. Now, obviously we have the dimensions labeled with variables, but our goal is going to be to, find what h is. So it also tells us the volume is going to be 86.625. So I'm thinking, well, is the volume somehow, this value, related to the dimensions of the box? And sure it is, right? The volume of a box is going to be equal to the length times the width times the height. So what that means is that 86.625 cubic inches should be equal to the length, which you defined as 2 plus h, multiplied then by the width, which is going to be 1 plus h, then multiplied by the height, which is just h. Now, what we're going to do with this problem is, I almost guarantee you're going to have a calculator handy for a problem like this. All right. If you don't, well, good luck. Not that it's not solvable, but you'd have to use something called the rational zero theorem. If you want to know what that theorem is, check out our channel, because I have about, I don't know, maybe 14 solved problems using the rational zero theorem. And you can then apply that to this problem. But you'll see it's going to take you an hour and a half to find the actual value. All right, because there's going to be so many possibilities. What you would want to do, though, is get your cubic function. You want to distribute this whole side, get it down to, h cubed plus b, h squared, and dot, 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 dot. Okay? And then follow the directions in those videos, which should be part of this playlist. But for right now, I'm just going to use the calculator. Okay? So what we're going to do is we're going to set this bad boy equal to 0. So you're going to subtract this value on over to the right-hand side. So what you're going to be left with is you're going to be left with the big old 0 on the left. And that's going to be then 2 plus h times 1 plus h times h minus then 86.625. Okay? Now, the reason why we set this equal to 0 is because when I plug this into the calculator, what I'm going to look for is I'm going to look for the locations where the function crosses the x-axis. And those values will be the values then of this variable that will produce an overall value of 0. In other words, it'll tell me what h should be to make this equation true. So go to y equals. Now just plug it in, parentheses, 2 plus, now you don't have an h, but you can just, x is fine. And then open parentheses 1 plus x. And then open parentheses again, just write x. And then just write minus 86.625. Let's just make sure everything looks good. Everything looks great. Then hit graph. And boom. Now it's going to cross the x-axis here. Maybe it crosses somewhere else. So all you're going to do is go to second table. All right. And you're going to kind of just analyze, what's going on here. When x is 37 and as it goes up, you see how the y value just keeps going, closer and closer to infinity. Right. So as we move down, see how it's going to go to negative infinity. Most likely, right? So there's a value somewhere in here where it goes from being negative to somehow being positive. It happens right in between 3 and 4, right? Right in between 3 and 4. And that's what we saw in the graph, right? It's right in between 3 and 4 here. Now, how do we find that exact value? Well, that's the beauty of the calculator, my friend. So here, hit second, trace. What you're going to do is you're going to call the 0 function here. So number 2, then what you're going to do is you have to move the cursor now to the left of the point of intersection. So notice your cursor is going to be starting at x equals 0, so just click over and get that to be somewhere around 3-ish. You don't have to go crazy. So right there is good enough. Hit enter. Okay. Then you're going to go to the right of the point of interest. So see the cursor moving to the right, just move it to the right. That's good enough. And then guess. Now you don't have to get it exact. You just got to get it close. If you were here and hit enter, you're fine. If you're here and hit enter, you're going to be fine as well. So just hit enter and look, boom. Calculated for you. Calculated for you. All right. Now, what this tells us is that the x value, so it tells us when x is going to be equal to 3.5, the function's value should be equal to 0, right? So if you were to take 3.5 and you plug it in for h, okay, which remember is x in our problem here, you're going to get this to be equal to 0. Now, if you don't trust me, you can calculate it, right? Do 2 plus 3.5, close parenthesis, open parenthesis, 1 plus 3.5, close parenthesis, open parenthesis, 3.5, close parenthesis, minus 86.625. Boom. There it is. So now you know the value of x, or aka you know the value of h. So the height is going to be 3.5. The width then should be 1 inch more than that, so that should be 4.5. And the length is going to be 5.5. Done. And you can also take these two, right? Take 5.5, multiply it by 4.5, the width, and then multiply it by the height, 3.5, and what do you get? There it is again, right? So there's so many ways to do it. So hopefully that helps, ladies and gentlemen. Thanks so much for tuning in. And if you like what you see, like and subscribe. And also check out our channel because we have, I don't know, thousands of videos out there, not only in mathematics, but physics and chemistry as well, where we solve specific problems. If you want to become good at anything, you got to practice. You can't just watch. So approach the problems, try to practice them. And if you have trouble, right, remember we go through the OpenStax books. If you have trouble, just view the video. We'll walk you through it. Best way to learn. Take care.